Okay, so the next thing that we're going to work towards are solving word problems, and we're going to specifically talk about two types of word problems today: real-life examples and consecutive integers. Because they are word problems in nature, the file that I'm going to use for the video is actually quite a large video file size, so I'm going to have to break this down into 3 parts. So please make sure you look for all 3 parts as you go through and start to solve these particular examples out. First wave is going to be all of our definitions, our steps, and a couple examples. Then I'm going to move from there and we'll do 2 or 3 more examples and then finish it out, okay? So be looking for 3 parts as you do this particular example. So the first definition that I have are based on consecutive integers, and that's wave 1 of what we're going to talk about today. If you were defining consecutive, we would say numbers that fall in a row. And remember that the word integers for us means no decimals and fractions, but every other number works. So numbers in a row that are integers could be numbers such as 1, 2, 3, 4, and so on. They're in a row and they are non-decimal or fractions. Negatives would also work, and I'll show you that with the consecutive even and odd groups. As we look at these, what I'm going to try to do is give you a formula that you can use to represent unknown consecutive integers. And what I need you to do is to use this formula as we solve the word problems that are consecutive integer based. So in order for you to get the formula, what we're going to do is say, I don't know the first number, the smallest number, which in our previous look was the number 1. But let's say I don't know what that smallest number is. The question is, what do I add to 1 to get to the next number, 2? And hopefully you say, I add 1 to it. And then you say, always going back to the smaller number, what do I add to 1 to get to 3? And that's a 2. And at this point, you should be recognizing a pattern that we're increasing by 1. And so if I wanted to represent by a formula 3 or 4 consecutive integers, my first number would be x, my second number would be x plus 1, and my third number would be x plus 2. Fourth number, if needed, would be x plus 3, and so on. So then the next one that we have are consecutive, so numbers in a row, but this time even integers, only the even numbers. And I am going to use some negatives here to show you that though 0 is not positive or negative, it is considered even. So if we look for our formula that we're going to use to represent consecutive even integers, we're going to do the same thing. The first number that we see is going to be our x, and you're going to say, what do I add to negative 4 to get to the next even number, the next larger even integer? And hopefully you can see that in order for me to get from negative 4 to negative 2, I have to go in the positive direction 2 steps, which is why it's plus 2. Going back to negative 4, what do I have to add to negative 4 to get to 0? I have to add 4. And there our formula or our pattern is established. Now notice that we have this 2 and the 4 and the 6 that are added to the x. That's because we're skipping over the odd number that we don't want. If you look at a set of numbers, they straggle between even and odd. So when you are looking for only even integers, you've got to skip over that odd number. And so as we look at our last number type for consecutive in a row, this time odd integers, we're looking at just the odd numbers. So we're skipping over the even numbers. So like we did before, if we say our first number is x for our formula base, what do we add to negative 3 to get to negative 1? Notice that it's still a jump of 2. We're skipping that even number that we don't want. And what's critical for you to remember is that if you see the word consecutive even as well as consecutive odd, formula-wise, they are exactly the same. It's what they equal that will yield for us their odd number or their even. Please hold on to that, because for a lot of students, when they see consecutive odd integers, they want to go x plus 1, and then x plus 3, and so on to use the odd numbers. And I do want to show you that if you do odd numbers, 3, and then I want to go 5 and 7, if I say my first number x is 3, If I added 1, notice I don't get to 5. I get to 4, and then all of a sudden I'm starting to go with even numbers. So it is critical that you remember that for consecutive odd numbers, it's never x, x plus 1, x plus 3. It's the same formula as consecutive even. And then the second type of word problems we're going to see are real life examples. And these are the hardest for me to give you a formula or a set of steps for. What we're being asked here is to solve for something. And so what we're doing is we're saying the variable that we're going to use is going to be what we're looking to find. And to make sure that when we use that, however things are added, subtracted, multiplied, or divided behind it makes sense for the problem. The other thing, as you're creating your equation, lots of times there's a variable, something that's changing, and that's what our variable is attached to. But then there's also a part that's set, that doesn't change, and that's usually our constant term. And I want you to make sure that you make that note, because what's set isn't going to change, and it's typically added or subtracted to that variable term, whatever it may be. So then the second thing I'd like to give you are your steps, the 5-step solving process plan that you're going to hear me verbally go through. The critical thing, and the one that actually I find a little bit hard for me to do, is I have to read the problem all the way through. Now sometimes when you do that, you might circle keywords that you know are important in the world of mathematics, and so it's a good thing for you to kind of find what works for you here. But read all the way through, especially looking for what is it that I'm looking for to find the answer to, so that I can define which one is the variable. Then you're going to choose the variable. And again, what are we looking for? What do we not know anything about? Are usually the questions you'll hear me say. We're going to create an equation, something that makes sense to the word problem. Then we're going to solve the equation like we did in the previous 2 times. And lastly, does your answer make sense for the problem? If I'm looking for a number of something, if I got a negative, does that make sense? No. If I'm going to buy tickets, can I buy 2.5 tickets? No. I have to buy integer or natural numbers, parts of it. So make sure that your answer makes sense for the problems. And what I'm going to do now is I'm going to actually go into part 2, and I'm going to separate all of the examples into 2 different sets. So these are the notes behind it. Now we're going to move into our examples in part 2 and part 3 of this lesson.